NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning bits of knowledge into a possibly tenable exoplanet. It obliges us as we set out on an excursion through space to uncover the secrets of Proxima B and find out whether it could be the next Earth we ought to take off into the vast expanse of space where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock, its real C. Proxima B is found a mere 4.2 light-years from us. This planet is covered in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? Anyway, wait, there's more. Proxima Centauri B isn't alone in that system. Around the red dwarf star it has a companion, Proxima Centauri C, and who knows what other mysteries the star system holds. Maybe there's another companion that we haven't yet discovered. The secret doesn't stop there. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps even life as we explore beyond our own solar system? We encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like wandering travelers in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet, with a year that lasts only 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly washed in sunlight while the opposite side remains in everlasting darkness. Now let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes RIL, also known as Alpha Centauri A and Alpha Centauri B. Together these stars form the closest star system to our solar system. The two stars RIL and Alpha Centauri B form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf or type star found 21 light-years from the other two stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima, in fact, means the closest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, which is much fainter than the human EY's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's projected to be, somewhere in the range of 0.23 to 54 cents, but it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, regularly stronger than the radiation we get from our Sun. That's right, it's so extreme that even the lightest particles of hydrogen are stripped away along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima b may not have a stable atmosphere, which is essential for regulating temperature and keeping a water-friendly surface. Without it, living creatures would be vulnerable to harsh space weather conditions, making life nearly impossible. So while Proxima b might appear Earth-like on the surface, it is far from being able to support life. Scientists remain somewhat cautious, as there are many factors that render it inhospitable. The mission to reveal the truth about Proxima b continues, and some still hold hope. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2021 and will help us determine if there is life on Proxima b. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima b can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light, can capture images of this light from the planet's surface, and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima b could be like Venus, with a thick atmosphere that is significantly denser than Earth's, and extreme temperatures that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima b is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider, with costs mounting. Space scientists are feeling the pressure to find ways to observe planets like Proxima b. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima b's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler: this cutting-edge technology could provide insights into the possibility of life on other planets like Proxima. However, like anything ambitious, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima b could be like Venus, with a thick, hot atmosphere that's inhospitable. Furthermore, get this: the James Webb Telescope can detect such emissions if it reaches a brightness of only 5% of the daytime side. Now, 5% may not seem like much, but when dealing with a star that's generally dimmer than our own sun. It's quite significant if Proxima b has advanced civilizations. They may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been named super Jupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiter's gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine seeing such a planet up close with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giants. See, these planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super Earths which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with an estimated mass of 7 Earth masses. It orbits in the habitable zone of its host star, and scientists are currently investigating whether it could be capable of supporting life. Proxima Centauri b is of particular interest because it is the closest potentially habitable planet to our own solar system. As we continue to explore these fascinating worlds, the James Webb Telescope promises to provide even more insight into their potential for life and habitability. The allure of Proximus Centauri belies not only in its proximity, but also in the tantalizing possibility that it may harbor conditions conducive to life. As we probe deeper into the exoplanet's characteristics, the question on every scientist's mind is whether Proxima b holds the keys to understanding whether life can exist beyond Earth. While it may be a rocky world, its orbital position within the habitable zone and its potential water presence make it an exciting target for future exploration. However, there's a catch. The proximity of Proxima Centauri b to its star means that it could be subject to dangerous radiation, especially given that red dwarf stars like Proxima Centauri are known for their violent flares. These flares, which emit intense bursts of radiation, could strip away a planet's atmosphere over time, making it difficult for life to take root. Proxima may also face tidal locking, a condition where one side of the planet is permanently facing the star while the other side remains in darkness. This could lead to extreme temperature differences between the two sides, complicating the conditions needed to support life. Yet there are still many uncertainties. We do not fully understand how the planet's atmosphere interacts with its environment. For example, could Proxima b possess a protective magnetic field that could shield it from the star's radiation? This would be crucial for sustaining life on the planet. Similarly, the possibility that life, if it exists on Proxima b, could have adapted to the harsh environment cannot be ruled out. Life on Earth, after all, has managed to thrive in even the most extreme conditions, from the depths of the ocean to the frozen tundra. Could Proxima b offer a different form of life, one that thrives in the face of challenges we cannot even yet imagine? In Addition to these considerations, Proxima B's proximity to Earth makes it a prime candidate for interstellar travel, especially with future advancements in space technology. While our current spacecraft like Voyager 2 would take tens of thousands of years to reach the system, more ambitious projects are being proposed. Solar sail technology, for example, offers a potential solution. Using the pressure exerted by sunlight, solar CS could propel spacecraft at a significant fraction of the speed of light. This method could bring us closer to realizing the dream of sending probes to explore distant exoplanets like Proxima Centauri b. The potential to one day send humans to Proxima b is an even more tantalizing possibility. While this prospect remains far off, it fuels our imagination and underscores the importance of continued exploration and research. For now, the James Webb Space Telescope will serve as our eyes into this distant world. It will monitor Proxima b's atmosphere, study its surface, and gather essential data to help us determine whether it can support life through its infed capabilities. Webb can provide us with invaluable insight into the planet's weather patterns, composition, and more, bringing us closer to understanding whether Proxima b could one day be a second home for humanity. As we move forward, it's clear that exploring exoplanets like Proxima b offers more than just the chance to find alien life. It also represents our desire to understand the universe and our place within it. Each discovery, each piece of the puzzle brings us one step closer to answering fundamental questions about life, the cosmos, and what the future holds for humanity. Whether Proxima b proves to be habitable or not, the journey of exploration will continue to inspire and shape our future.